So this video is detailing how we can assign oxidation numbers. This is out of chapter 8 in your textbook. This is number 68, which is a bunch of different parts just going through and assigning different oxidation numbers. Our first example being Cl2. And so in red, I will be writing the answers or the oxidation numbers for each particular element that we have. So with Cl2, pretty simple diatomic here, and this is how chlorine actually exists naturally. So if an element is in its natural state, it has an oxidation number equal to 0. And so chlorine is a diatomic naturally, and so that's why it's going to have a 0 oxidation state for both of those chlorine atoms within the molecule. Part B looks at the ferric ion, and so remember that the sum of oxidation numbers must equal the charge on the molecule, or in this case, element. So since the iron is in a +3 charge, that's why its oxidation number is also +3, right? Because the sum of the oxidation numbers must equal the charge, in this case monoatomic +3, so the ferric ion is in that +3 oxidation state. C looks at copper chloride, cupric chloride, and so here's where you want to have the most electropositive element. Is going to possesses the positive oxidation number, while the most electronegative will have the negative oxidation number. And then lastly, the sum of these oxidation numbers must equal the charge on the molecule. So if we look at where these guys kind of fit, we should begin with the chlorine. The chlorine has an oxidation number of -1, right? It likes to have a -1 charge, and getting to its noble gases, group 7b, those guys all like to be -1 in charge, and there are actually 2 of them. Since there are 2 chlorines, really the total oxidation contribution from both the chlorines would be a total of -2. So that's defining the most electronegative element and giving it its negative oxidation number. We then go to copper. Copper must then balance out the oxidation numbers, and so it's going to have an oxidation number of +2. And so the +2 and the -2 cancel, and that's why the copper chloride then has no charge to it. Going to E. E looks at dichromate. And so here's where we actually start to see charge have an influence on this. So as far as looking at this kind of like before, with these go-to elements, oxygen is a great one in that it possesses or always wants to have a -2 for its oxidation number. So if we think about that, our oxygens are going to be all in that -2 oxidation state, and there is 7 of them. So the total contribution would be -14 from all of the oxygens in the molecule. That means the chromium would have to have a total of +12. Now, why the +12 idea? Really, that comes from the sense of the charge. That in order to get an overall charge of -2, I have to have a difference in the oxidation states. And so having a -14 from our oxygens, a total of +12 from the chromiums, gives us that -2 charge. So that means that the 2 chromiums together have a total of +12, and so individually each one would have a +6 oxidation number, dividing by 2 in this case to actually figure it out. So we do the go-to elements first, like the oxygen, then balance out oxidation number and charge with the transition metal. In this case, the transition metal being chromium. In the earlier example in part C, it was actually the copper at the very top there that we saved for last. Again, a transition metal, and we're seeing the same thing with part E here. The last part to this would be F, which looks at this sulfate-containing molecule, hydrogen sulfate here. And again, we're going to have those go-to elements that are going to help us by where they're placed on the periodic table. Oxygen is a great one here, again with that -2 oxidation number that we always see. And another good one is hydrogen, being in group 1A, likes to have that +1 oxidation number. So if I take those two and put them into the formula at the top here, that, well, the hydrogen would be +1, the oxygens would be -2, giving us a total from the oxygens of -8, because there are 4 of those oxygens there. That means I have to have sulfur of a particular charge, and the particular charge that it would have would be a +6 oxidation state. And again, that comes from the combination of the oxidation numbers to get that total charge that we have of -1. That -1 has come together of the hydrogen and its oxidation number, the oxygens with their total contribution of -8, and so that means that the sulfur must be in a +6 oxidation state in order to get the overall -1 charge for the molecule. So that's how you assign oxidation numbers. Always begin with the go-to elements, like group 1A, group 2A, group 3A, being +1, +2, and +3 respectively, as well as oxygen having that -2. These are really good go-to elements. That is how you assign oxidation numbers.